So for this video, we're going to be looking at a sample population of orange, rainbow, and green beaked toucans with the initial allele frequencies and genotype frequencies listed as seen here. So the population was previously in Hardy Weinberg equilibrium as all of the boxes were checked. There was an infinitely large population, random mating, no selection, and no migration or mutation, but then randomly mutation occurs, and the rainbow heterozygous big B little b pattern is then selected for. So now let's see what happens in the subsequent generations.
So since we now have the information to know that our sample toucan population is violating the Hardy Weinberg equilibrium principles, we can use the equation and the initial frequencies previously given to determine some more about this population in their future generations. So we have the initial frequencies already listed, and I have given the fitness of each genotype as based off the information presented in the previous slide. So to calculate the unadjusted survivors of each genotype, we're going to take the initial frequency and multiply it by the fitness. So for big B, 0.23, big B, little b, 0.24, and little b, 0.15. We will then subsequently add all of these together to get the average fitness, which in this case is 0.62. This number will then be used and divided by the unadjusted survivors of each to get the frequency of each genotype in the future generation. So for big B, we have 0.37, big B, 0.39, and little b, 0.24. So we'll then take this frequency information, which we can use to calculate the frequency of different alleles and genotypes in subsequent generations. So I've already written out the allele frequencies. So I'm going to walk you through how to solve for genotype frequencies of each. So we basically use the separate components of the Hardy Weinberg equilibrium equation to solve this with the information given in the table. So for big B frequency in the population, we will use p squared, which in this case you can see is already given here, so which will be 0.565 squared, which equals 0.319. So for big B, little b, we'll use 2pq, so 2 times 0.565 and 0.435 given from this information here, which yields 0.492. So for little b, we will use q squared as here, 0.435 squared, giving us 0.189. So here we have the future frequencies of the alleles and the genotypes within the population of toucans after Hardy Weinberg equilibrium has been violated, and as we can see based off the fitnesses, we have stabilizing selection shown as the heterozygote is chosen for, and in subsequent generations will be increasing in number.